Hey guys, I wanted to jump on here for a few minutes and discuss basically some items that I think some of you might be confused about, mainly this digital notebook, a little bit of concepts over enzymes, and then our Zoom meeting tomorrow. So I'm in Google Classroom now. One thing you'll notice I did post this morning is Zoom meetings or our Zoom meeting times. I want to go ahead and just make sure you're aware that you can jump on any of these times tomorrow, just as long as you're in one of those times. I'm going to give some information and answer questions that may be confusing for some of you right now. I did go ahead and answer or go ahead and enter grade, sorry, yesterday, and some of you may have noticed that you received zeros on some items, and we need to discuss that so that you understand why, and maybe we can fix that if you'll jump on and or send me those questions. Also, real quick, let me just clarify. This is to be taught as if you were sitting in the classroom. I know it's very different, but the work I'm giving you is not to replace face-to-face work, but it's to be comparable to face-to-face work. So yesterday, all I gave you was vocabulary, and I posted a video, and I asked you like 4 or 5 questions about that video. Very doable, and I know you do have other classes, but I don't think I'm overloading you with work. Today you had to watch an Amoeba Sisters video and answer some questions and practice a an enzyme quiz. So please make sure you're doing the work that's assigned because I am checking that. All right, so these are the 3 Zoom times. There's one at 11, there's one at 12:30, and there's one at 2. Please pick one of those times and jump on, and we'll discuss what you may be struggling with. Now, notice I'm in a Google Classroom. This is my 4th period. They look identical. It doesn't matter what class period you're in. Scroll almost to the bottom, and you will see where it says digital notebook right here. I'm going to jump on. Actually, I'm going to change class periods real quick and jump on down to digital notebook. I just need to go through one thing with you, and please bear with me. Do not stop this video. Open this digital notebook. I know you see some of your names. I do want to make sure. I'm looking for my daughter's name. I added her to one of our classrooms so that I could show a student view here. So bear with me because I can't remember where I added her. Let's see. Right here. There she is. Okay. So when I say, Kobe, I think you've added a copy to everybody's. I'm not sure. We'll go over that later. But anyway, I'm going to scroll on down. When I say that you have to do slides 15 through 19, look over here to the left where this cursor is. Those are the numbers I'm referring to, and this may be simple for some of you, but I'm getting some questions. So when I say, hey, do slides 15 through 19 to get credit, that's what I'm referencing. So you click on here, just like I showed in my last video, and you type, what are biomolecules? And you start, well, you don't drag that, but you start typing, and you answer those questions. All right, and then you go to slide 16, and my calendar is going to pop up in a second, so ignore that. Then you start dragging these things over here, like they're supposed to go, and so forth. And then when you get to slide 17, you start dragging these pictures. Most of you have done this and did a great job, but I have about 8 of you that have a 0 for this assignment. I need you to look at the video posted last Tuesday, and it's on YouTube. It's also in Google Classroom, and see if you can figure out what the heck you're supposed to do with these slides. 2 of them are completed for you. The other ones you just have to go in and complete. So please make sure that you're doing that. Also, you all have a copy of this. You should not be making copies and doing all this stuff when you go in and edit this. It should be all there for you. All right, so what you're going to be assigned, oh, my lights just went off. No big deal. What you're going to be assigned to do next, and I'm going to do some of this for you, starts on slide 22 right here. So slide 22 says, hey, here's a cool enzyme article. You're going to read it, and you're going to look at it and say, holy crap, this woman's crazy. That's a lot to read. It's really not, and it has a ton of cool information in it. Well, cool if you like biology. So you're going to go through here and you're going to read what is a catalyst and what is lock and key, and these are the three things that make an enzyme quit working. I'm sorry, not yet. These are the three things that help an enzyme work. And then you're going to read the next page, and it's going to talk about the three things that make an enzyme not work. So you go through here and you read all of this, and it helps you really get a better idea of enzymes. Oh, I think I look better since the lights went out. Okay, anyway, side note. All right, so then you're going to go back up here, and you're going to fill out the enzyme article. Now, here's where I'm getting some people with questions. If you want to, and I'm totally fine with this, you can get you a composition book or a 3-ring binder with some notebook paper, and you can fill all this out in those. That's fine. Here's all I ask. Snap a picture of this when you get done. Upload the picture in Google Classroom right here. Now, I know you already have a grade right here for this assignment. Right here, it says 100. Not, oops, let me change this there. Not 0, okay? It probably says 100. That's fine. If that's the case, then I will go in and make another comment and give you, once you complete this, a 100. These are big grades because this is like, okay, you did this. This is major stuff, so I'm going to give you a 100 for this. So when you go in Power School, you'll notice these point values are big. All right, so if you feel more comfortable doing this in a notebook because you like to write stuff down, I am cool with that. You just need to make sure when I look right here under the name that I see pictures that have been uploaded. Don't email me. I get 78,000 emails a day, and I can't keep up with my emails. Upload it. Don't send me it in a text message picture. You can text message me, that's fine, but don't send me pictures because I can't find that stuff. I won't keep up with it. All right, so you're going to do a 3, 2, 1 on this page based on this article, okay? Then you're going to answer these questions. Google, you can Google, what do catalysts do? Google, what do catalysts do? Fill it in here. Again, write it down if you want to. Keep your notebooks. We're going to start using notebooks if we get face-to-face, when we get face-to-face. So if you want to start a notebook, that's fine. If you're using a digital notebook like I'm asking you to do here instead, then we'll have this digitally, so when we get face-to-face, you'll have your stuff already too. Either way is fine. All right, let's go through this together. So what this is asking you to do is slide these yellow headings here. So this is reactant or substrate. This is chemical reaction. This is activation energy. Oops, like that. Okay, so the reactant or the substrate would basically be the thing that starts or the thing that gets going, the thing that fits into the enzyme, the left-hand side of a chemical equation. So if I'm making a cake, it would be everything that goes into that batter. The flour, I'm not saying a Betty Crocker out of a box. I'm saying we're actually making a cake. So we read these things. The amount of energy needed to make a chemical reaction start. Substance that are changed during a reaction. The beginning substances. Oh yeah, that sounds good. Let's drag it right over here, and it doesn't want to drag. So I'm going to drag it over here. Again, if you're doing this guy, just draw these charts in there. Okay, draw them in there, upload a picture, life is grand. Okay, chemical reaction, the breaking or creating of bonds, love it, drag it over, we're done. And then activation energy, read the definition, the amount of energy needed to make a reaction start. Beautiful, let's drag it down there. There you go. There's 3 words, 3 definitions. Now these charts are a little tricky, the graphs are, so I'm going to do those for you. This first one, is activation energy. How do I know that? Because it's, and I know this is tricky, but it's pointing to this little red line right here. I don't expect you to know that. It's pointing to this little red line right here, which is the energy required to get you up over that mountain and down. Whoop, I'm out of the screen. Get you up over that mountain and down the hill. It's, if I'm pushing you up a hill, it's the energy I need to get the reaction going. And then chemical reaction is this one. And that is just basically the reactants are here, the products are here, so that's the normal reaction. And then this is the substrate, which is basically telling you, hey, these guys are going to fit into this guy to make this guy. This is the enzyme. These are the substrates. Not the best diagram. And these are the reactants. If you're keeping this, do I have it right? Yeah. If you're keeping this, draw these diagrams. They're not hard to draw on a sheet of paper. Not hard. Pause the video, draw it. This slide is done. If you're doing your interactive notebook, pause the video, drag and slide. This slide's done. Next slide. Drag your yellow headings. Let's do product first. We're not going to worry about endo and exothermic. So we're just going to say, oop, not today, guys. That's more of an upper level. Let's just do product. Substances that are okay, whatever. Substances that are made by a chemical reaction. There you go. And then products. I can't read these. Quit being weird. Right here. It says these are the reactants, these are the products, and there we go. The difference in these, exothermic means it releases heat, endothermic means it brings energy or heat in, and we're not talking about that yet because that has to do with photosynthesis respiration. So that's all I want you to do on that slide. All right, so that's slide 27, done. Slide 28, we do need these. We're going to start with enzymes, slide it over. Again, if you're drawing in your notebook, draw it over. Then we're going to go to active site, slide it over. I'm going in a hurry because I want to make this video as short as I can. Denaturation, slide it over. Pause the video if you need to. Then I'm going to do my definitions. An enzyme is a type of protein, that's important, made of amino acids. And an enzyme's picture, I'm not real sure which one of these is supposed to be used for that because they're both enzymes. So let's choose, let's go with this one. No, I don't like that one. Let's go with this one because the green is the enzyme. If you want to make a note, if you're writing this down, this is the enzyme, the green. The blue is the substrate. This is the substrate. This is the enzyme substrate complex. And then this is the product. The active site picture, the active site is the location where the substrate docks with the enzyme, right here. So that's exactly where everything fits together, like my hands fit together. That's where my key and my lock are going to go together. In my previous video I talked about. And I'm going to drag this little baby over here. And that active site is that little area. I don't have the best cursor to show this, but the little, about pointed, like y'all could see that. The little valleys, the little things that are going whoop, dee whoop, dee whoop, like that. And the blue thing morphs into the valleys. That's the active site. And then this picture is of denaturation. Basically what I have here, what I'm trying to have here, here we go. Move on over, is a check mark, and when it's heated, it changes shape. When it's heated, when it's exposed to extreme pH, when it's exposed to a salty environment, then what happens is the shape of that changes from a check mark, like you see right here, to this little whoop-dee shape like that. And that is very different than these shapes right here. So where a substrate may fit here, it ain't going to fit there. So denaturation is not good for the enzyme. The enzyme and the active site, instead of doing this, the active site might change to this, and the substrate's trying to fit, and it can't. So that causes problems. Pause it, write this down in your notebook, or drag into this notebook, into internet land. Sorry, I'm a little weird sometimes. Okay, then what? Ways to change the rate of a chemical reaction. This is just listed for you. Then it goes through and talks about this. I want you to not go further than this page right here. So at this point, in this video, we are going to stop at slide number 28. So your assignment is to start at 22, read the article, fill out 25, and get these charts completed. So 22 through 28. If you have any questions, we'll be on Zoom tomorrow, or you can email or text me those questions. Hope y'all have a great day.